Hi all, welcome back to the GMAT Quant practice. Let's understand this interesting question. It says that how many four-letter words can be created using the letters of the word achieved. Now we have to create four-letter word, right? So we have four slots which are to be filled. And how many alphabets we have? We have 2, 4, 6, and 8 alphabets in which A is coming one time, C is coming one time, H is given as 1, I is given as again 1, E we have 2, and V still 1 with D also 1. So these are the 8 alphabets in which E is coming 2 times. All the alphabets others are distinct alphabets. Now, how can we form four-letter words? Can we say that case number 1, there will be some words wherein all the letters of this word, which is four alphabet word, will be distinct. All distinct alphabets, all distinct alphabets are there, and there will be some words, case number two, wherein E is coming 2 times, right? There will be some words where E is coming 2 times, and the other 2 will be from the other remaining letters, that is A, C, H, I, V, and D. So E comes twice in this particular case of case number 2. Now, coming to case number 1 again, all distinct. How many alphabets we have which are distinct, right? So that is A, C, H, I, E, V, and D. So these are distinct. We are not taking E as 2 times. We are just taking words wherein E is coming just one number of times, right? It's not repeating. Now, in how many ways can we pick 4 letters out of these 7 letters? That will be 7p4, right? Why permutation? Because you know that order matters here. And whenever order matters, it's a question on permutation, right? Permutation. Why? Because let's say ASACHI is a word, ACHI. Similarly, this will be a different word if we have AHCI. So same alphabets, but ACHI is different from AHCI. That means it's a question on permutation. Out of 7 distinct alphabets, we require 4. In how many ways? That will be 7p4, right? We can calculate this later. Let's understand case number 2. Now, case number 2, E is coming 2 times. If E is coming 2 times, the other 2 could be different, right? There'll be the different alphabets which we can use in these 2 slots. We don't know which all different. It could be AC, it could be AH, right? We don't know. Let's consider this as X and X, right? These 2 will be somewhat different from each other as compared to E and E also. Whatever these 2 cases, we don't know. Now, what can be said? How many ways you can rearrange these 4 objects? These 4 objects can be arranged in 4 factorial ways, and there is a repetition. E is coming 2 times, and these 2 different alphabets, they are also coming 2 times. So whenever there is a repetition, divide by that factorial. So 4 factorial upon 2 factorial into 2 factorial will be the number of ways in which these 4 objects can rearrange within themselves, right? Now coming to this part, E, you just have for this position only one choice. Second position, again E, only one choice. Third position, this slot can be filled with remaining 6 alphabets or 6 choices, 2, 4, 5, and 6. So there are 6 choices for this particular slot. Now you have already used one alphabet. How many slots for the next alphabet? You now will be left with 5 choices. Multiply this with number of ways in which they can rearrange. So that is 4 factorial upon 2 factorial times 2 factorial. So this will be the total number of ways in which 2 E's are coming. How many words can be formed? These many words can be formed using E twice, right? Other 2 alphabets will be different, but E will coming twice. In first case, all the alphabets of this 4-letter word will be distinct. Now, using the formula, We know 7p4. Let's write here. What is 7p4? That is 7 factorial over 7 minus 4. That is 3 factorial. 7 factorial, 7, 6, 5, 4 times 3 factorial over 3 factorial gets cancelled out. 7, 6 are 42 and 20, that is 840. So these are 840 ways which or words can be formed using all the alphabets which are distinct. Now, how many ways can be formed such that 2 e's come? 2 e's come. Let's simplify this. 6 into 5, that is 30, times 4 factorial, 4 into 3 into 2, divided by 2 times 2, divided by 2 times 2. So this is going to be 4, gets cancelled out. 30 times 3, that is 90, 90 times 2, that is 180. So either case number 1 or case number 2, right? We have case number 1 or case number 2. So whenever cases come, you have to add them. Cases means is this case, it could be case 1 or case 2. So whenever case comes, how many ways? In the first case, there are 840 words. Or means to add. Case number 2, how many words can be formed? That is 180. And our answer, that is 180 plus 840, that is 1020. These many words can be formed. Option D is the correct one here. I hope you got the understanding. If you like the video, just subscribe to the channel.